Hi, I'm Michael Cole, and today I'm going to talk about binary trees, objects, and arrays, and where you would use them, why you would use them, and the advantages and disadvantages. Most people think of computers as ones and zeros or binary code. Some people even think of programming languages such as Java. In reality, it's much more. The real power in Minecraft comes from the multiple data structures that are used to build out the world around you, simplify actions like moving around or crafting a sword, or even hitting a pig. A few key data structures are arrays, binary trees, and objects. As we look deeper into Minecraft, it uses each of these three data structures in creating the virtual world we play in. For example, animals, characters, mobs, building materials are all cube-shaped objects. The entire world is constructed of these objects and are placed in a three-dimensional array, x, y, and z. By assigning these objects positions in an array, you can build and redraw the whole map around you. Finally, anytime you have a list like a server, you're more than likely going to be using a binary tree. So let's take a closer look. Objects are based on a classification of items called a class that have common attributes. Let's stop for a second and take a look around your house or area and see what type of item classes there are around you. For example, we've got a couch or a chair, which is common in attributes because you can sit on it, you can move it, or if you were to choose a chair, what type of chair is it? What color is it? What happens when you sit on it? Another furniture type would be a desk, but you may not want somebody to sit on it. Okay, let's look at more concrete examples. Here I've got three objects, each of which are classified under the same category of fruit. We've got a lemon, a lime, and a tomato. They have similar but different properties, which makes them under the same category. Here we've got a lemon, which is yellow and has a yellow core. Our lime is green but is smaller than a lemon, and our tomato is red, and the taste differs from both of our citrus fruits. Properties like size, color, weight, as well as defining an object through actions and behavior are required. What happens when I cut into the lime or throw the tomato at the wall? What if I want to know what type of lime this is? The object handles the details all for you. Here are a few of the benefits. The ability to do complicated things with an object without knowing the inner workings is called abstraction. Putting all the properties and actions around an object in a single place is called encapsulation. So all things lemon are in one object. Inheritance is when general objects like fruits have things in common. You can code most of it in its base class, fruits. So if I wanted to try and model a new fruit type like a banana, it simply inherits all of the base fruit class. It's also a lot easier to code and maintain objects as you can model the real world. Objects are a way of thinking. There are not a lot of limitations to it compared to other data structures because you can actually implement an array and binary trees as an object. Objects also require you to use object-oriented coding, which is typically much more complex than other scripts like Python. Now let's take a look at arrays. An array is a data structure that contains usually items and objects or numbers, which can be retrieved using a specific position. Now let me demonstrate using these cards. So, an array, I'm going to first push down an index 0 position. Here's index 1, 2, 3, 4, 5, and it keeps going. Here we have an array from the index 0 to index 5, starting at 0, 1, 2, 3, 4, 5. If I were to ask the array for index 2, it would give us on the screen value 46, and this card, the 3 of hearts. On this next slide here is a two-dimensional array that I created for a project a while back. It's being used to map out an adventure game where 0 equals open space, 1 equals a wall, 2 is a tree, and 3 is water. This is the exact replica of the map, but it's being used to lay out objects and treasures. Notice it's 1-to-1. Now, looking back at the Minecraft world, the whole thing is set up on a three-dimensional array, x, y, and z. So if a player is standing at the coordinates 10, 67, 30, 1 to move forward, 1 in the direction x, the computer would check the location 10 plus 1, 67, 30 to see if the player can move there. Another array within Minecraft would be the inventory hotslots or hotbox. I'm sure that there's more arrays inside of your favorite games and even Minecraft. Can you think of any? Unfortunately, arrays come with a few disadvantages. Let me demonstrate using this deck of cards again. You can go to an index quickly, but you may have to search through the entire array to find a value you want. An array that's only 6 long is much quicker than an array that's, say, thousands long. When adding or deleting an entry, every position from then on must be shifted up 1 or down. So if I want to delete the 3 of hearts, every single position from there on must be shifted down which is quick on this, but if it was, again, 1,000 long, it would be a lot slower. Same goes if I want to reinsert something. If I wanted to start it back, everything would have to be shifted up again. Also, arrays do not remember any of the previous searches, so if I were to go through the array to find the value 3 of spades, I would have to go through the entirety of the array again to find the 9 again. If the search value isn't in the array, I have to search the entire array to find out. Last, we have binary trees. The very first number or item that is inserted is called the root. From there, it's a system of sorting. Starting with the root node, which in this case is the 50, anything that's less than is going to go to the left, and anything that's greater than is going to go to the right. These are called the left and right children. The more items there are in a tree, the larger the tree is going to be. In this case, the 67 is considered a leaf node, which means it has no children. Let me demonstrate to you this using another deck of cards. Here's how you build a binary tree. If you have a deck of cards close by, you can try building one too. Starting with our root number, in this case a 7, we're going to build down. A 5 is less than 7, so we're going to put it down to the left. Our 10 here is greater than 7, so it goes to the right. Our 8 here is greater than 7, so it goes to the right, but it happens to be less than 10, so we'll put it to the left of 10. Our 2 is less than 7 and 5, so it goes down here to the left of 5. Our 6 is less than 7 but greater than 5, so it goes to the right of 5. And then we have an ace here, which we're going to treat as a 11, which is greater than 7 and both greater than 10. Finally, if I want to append a card, in this case, queen, we're going to have to go through the whole thing, and you have to find the perfect spot for it. Our queen is greater than 7, queen is greater than 10, but it happens to be less than ace. So it's going to go here. When it comes to searching for a card, it's a lot easier because you simply just go greater than or less than. We know our queen is going to be greater than 7, it's going to be greater than 10, but it's also going to be less than ace. There we find a queen, and that only took us 4 searches out of all these cards. As you can see during this demonstration, I only had to search 4 times in order to get to the queen, but if this was an array, I would have to search through every single element in order to get to the queen. In a tree of, say, 1024 items, I would only have to search a maximum of 10. That's because log base 2 of n, or in this case, log base 2 of 1024 equals 10, where an array would search all 1024 items, meaning that trees are a lot more efficient and is a quicker way than arrays. Trees are also quicker to insert and delete than arrays. However, the logic is a bit more complex than I can explain in this time. Binary trees are also always ordered alphabetically or numerically. On the downside, trees require more memory than arrays do to holding the search value itself, and additionally, the pointers to the left and right children. Also, appending data takes a lot more time than it would during an array because you have to find the specific position. Finally, there is no way to access a given position because there's no 10th position or 9th position. So let's wrap this up. All in all, data structures are a huge subject. Some of the thousands of data structures include hash tables, balanced binary trees, sparse arrays, neural networks, and linked lists. Donald Knuth's series, The Art of Programming, has 4 books, each over 1,000 pages long, that goes farther in depth about data structures. By this point, I hope that you've realized that there's never one perfect solution for a job. There's an old saying that goes, to a man with a hammer, the entire world is a nail, which means you have to find the perfect fit tool for every job. Objects, arrays, binary trees are just general data structures that goes to show the effectiveness of a different approach completely changes the solution. Now I leave you with a riveting slide, APA formatted references. Thank you.